Moreover, what if the constant term is not there? That is, we just have a1x plus b1y is equal to 0 and a2x plus b2y is equal to 0. Obviously, when you have two lines which do not have the constant terms, what does it mean? Yes, it means that both the lines pass through the origin, which means the origin is the point of intersection of these two lines. So already, without actually knowing the equation of the straight lines, you know that both these lines pass through the origin, which also means that the origin is their point of intersection. However, can we write down the joint equation of these two straight lines? Again, in the same way, by multiplying out the left hand side expressions of both the equations. a1x plus b1y, a2x plus b2y, both being equal to 0. So we get a1, a2, x square plus b1, b2, y square plus a1, b2 plus a2, b1, xy is equal to 0. It is not possible to get any other term, and thus we see that it falls neatly into the pattern ax square plus 2hxy plus by square is equal to 0, which is known as the homogeneous equation of second degree. We thus see that whether it is any two general straight lines whose equations are of the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, or a couple of lines which are passing through the origin, their combined equations will be of the form of the general equation of a conic. Especially if the two lines are passing through the origin, then their combined equation is called the homogeneous equation of second degree. So therefore, there has to be some way to identify the characteristics of the two lines in the combined equation by observing the two equations. The first of those is the value of the coefficient of xy. Thus, ax square plus 2hxy plus by square is equal to 0 represents a pair of straight lines y equals m1x and y equals m2x, which are real and distinct if h square is greater than ab, coincident if h square equals ab, and imaginary if h square is less than ab. As you can see, they form a quadratic with h square minus ab as the discriminant, and that is how you get h square greater than ab, which gives us two different values for the values of slope, which indicates two different lines. And if h square equals ab, then the discriminant equals 0, and that gives us exactly one slope, which means that the two lines which are being discussed are essentially the same line. That is, the lines are coincident. Or if h square is less than ab, then the discriminant is negative. Square root of a negative number is not a real number, and thus the two lines which are being discussed are imaginary lines. That is, they do not exist in the real plane. However, we can find out if you have two lines y equals m1x and y equals m2x, right? We can write the equation of two lines which are passing through the origin in that form. Yes. So if m1 and m2 are the slopes of those two lines, then the sum of the slopes of the lines, that is m1 plus m2, is obtained by minus 2h upon b, and the product of slopes is obtained by a upon b.